Hello friends, welcome back in this another video tutorial of SolidWorks 2016, where I'm going to show you once again that how to assemble the vise or the machine vise. Okay, so the part or all you need is in this video. Basically I don't going to repeat the process, or you can say that this video is not about to how to create the parts, but how to assemble the parts, the machine vise assembly. So I have previously uploaded that video, but this time I'm going to show you some advanced features included, like screw mate and limit mate in the machine vise. So first thing first, all you need is to click on the assembly. Okay, browse the content. Okay, so here is the body, open it. So this is the body of the vise. Now it is time to import all the files once again. So one by one, what I'm gonna do, let me, sorry, this is the previously used assembly. I need to fix that thing. Okay, so just to put here. Now click on first and the last, just leave the assembly as it is. Now place the part one by one so that it will be more easier for us to find out where exactly everything is. Okay, put it over here. That's it. These are the all parts that we required for this assembly. As you can see here, this is the movable jaw, and this is the handle which we're gonna use to rotate this screw rod. This is the jaw, and this part is called the clamping plate. This is washer, this is nut M8, and this is lock nut M10, and this is the screw M6, and this is the cap which is going to be fitted right at these parts. Okay, so first thing first, I'm going to double the amount of some parts, like here this handle. I need these two because these are going to be fit in these two holes. So click control and left click and drag it over here. So now these are two parts. Now we need screws. How many? 1 2 3 4 5 6. Okay, so one is there, control and left click mouse and drag it. 2 3 4 5 6. Okay, so we have 6 screws, and this jaw we need 2 of them. So this is the first going to be fitted over here, and the another one is going to be fit over here. So again, control left click and drag it. That's it. So these are the all parts that we need to assemble the machine wise. So for the first thing, what we going to do, we are going to click on the mate over here and click this surface and this surface and going to coincident and click right, and for another mate click this bottom part and this upper surface and make it coincident and click OK. Now as you can see here, the part is sliding right through the main body. This is sliding right through the main body. So for this purpose we are going to use the limit mate so that this movable jaw just slides between these recession or the cavity or whatever it is. It has to be moved from this point to this point, not like this. So we will do this. Okay, so before doing the limit mate, what we're gonna do is I'm going to place this over here. How we're gonna do this? Select the bottom surface and this surface and make it coincident, click OK. And so as you can see here, the distance or these holes are not right through, not like on the center of these 2 points, but is like offset from the center line. So this is not in at equal distance from these 2 distance, so we have to check what goes where. So take the shortest length from the hole and mate it over here and coincident, click OK. Now this surface and this surface coincident and click OK. Now as you can see here, the holes are just concentric with this. Going to change the wireframe structure. As you can see here, it is perfectly aligned with the hole. Going back to the solid. So repeat the process, same at this point. Take the shorter distance, click over here, coincident and right. Okay, so the back face and this, make it coincident and click right. Now at this surface and this surface, make it coincident and make it right. So everything is perfect at this moment. Now this is also coincident with the hole. So far so good. Now it is time to fix the bottom plate, or we can say that the clamping plate. So as you can see here, it also has the top and bottom face, the screwed view and the flat surface. So this part and this part, rotate it to make it downwards and click OK with coincident constraint. Now make it parallel because it is at some angle. To make it parallel, click on this and this, make it coincident, it is already parallel and click OK. As you can see here, it is a bit off. Sorry. Now as I can drag over here, it is perfectly aligned with this edge and this edge, but not at the center of these holes. For this purpose, I'm going to make it concentric with the holes, something like this. Now it is perfectly aligned, not going anywhere. Now it's time to fix with the help of screws. Click the cylindrical part of the screw and this hole. Make it concentric and click OK. Now it is aligned. Now as you can see here, select the tapered or angled surface coincident or with this angled surface. Make it coincident and you can see it is perfectly aligned at this surface. Now repeat this process with all the 6 holes. Okay. So this jaw part is fixed with this screw on the body and the sliding part. Now it is time to fix the bottom screws. Now select the screws and repeat the process. Now as you can see here, the screw is in another direction instead of the downward direction. To make it align with this surface, click on Flip Mat Alignment. Now the screw is downward. As you can see, we are not able to see this part. It doesn't matter. It is there. Sorry, it is not visible at that moment. The screw is right inside of it. Okay. Okay. Now select that contour and align it with this surface. Done. Now for the last screw, drag it over here, select the cylindrical part and coincident with the surface, turn it upside down, select the tapered and coincident it with here. So everything is at its place, not exactly, these are still outside of it. Now what we are going to do, it is still sliding through the body or penetrating through the body. Now it's time to align this and this and click OK. Now the shaft is here. Okay, take this surface and coincident it with this surface, click OK. Now the shaft is through this, but it is still something like this. Don't worry. Now it is time to place the washer. So this is the washer. Select and select this surface. Now it is already coincident with it, and select the cylindrical part and outer cylindrical portion, make it concentric and click OK. Now it is time to align this. Make this surface, or the bottom surface, exactly the bottom surface, and this surface, make it coincident. Now select the inside of this cylindrical contour and select this, make it concentric and click OK. It's time for the lock nut. Select the bottom surface and this surface and click OK. Now select the cylindrical inside and this one, make it concentric and click OK. Now you can see here we are almost done with this process. Now it is time to put these handles through these holes, but for doing this I have used a small, you can say a cheat, or because if you're gonna simply select mate, select this contour and this one, make it concentric and click OK, it goes something like this. Okay, at this part or at this moment I really don't know that how to make it perfectly at the center. So if you guys have any idea or how to make this handle right at the center, so please write below into the comment section. But I have figured out something that how to make it perfectly at the center, or for this purpose what I did is, first of all I need to delete this mate. Okay, so for this purpose, handle, as you can see here I have created a sketch. Okay, these sketch helps me to, these are not, as you can see here the sketch is not something like this along the diameter of the shaft, but opposite to the diameter of the shaft, facing another direction, but the diameter of this circle is same as that of the diameter of the shaft, major diameter you can say, right at the center of this handle. So for mate purpose, select the mate, select the cylindrical shaft and the inside of it, make it concentric and click OK. Now it is not at the center, it is still fluctuating very unevenly, so what I did is select the circle and selecting this point, exactly this point, and click OK. Now it is perfectly at the center and will rotate smoothly. So that is why I'm saying that if you have any idea how to do this in another way, you can write into the comment section, because there are lots of things, or there are lots of different way we can design. Okay, now here is the difficulty that we are not able to see the another mating for this one. So for this purpose I'm going to change it to the wired frame structure again, and selecting the circle, and this is the point. Okay, so it will automatically align to this direction. Now convert back it to the solid path, and we can click on it, click OK. Now I can click on the circle and hide it. Now it is not visible on the screen, but it is there and it works like a good thing. Okay, now it is time to make the mate for this gap at this end. So we need 4 of them. 1 2 3 4. Now we need to create copies. Same, repeat, control left click and drag it over here. We have 4 parts of the gap. Now click on mate, make it concentric with this one, flip the direction, click OK, drag it over here, select the bottom part, and this one make it coincident and click OK. Now repeat this same process at all these 3 points with this gap. Click OK. It is very interesting. I feel very happy while all doing this thing. So everything is done with the mating of the part. So this is the part first of how to assemble the bench vise or machine vise into its all specified position. But now it is time to make this error. We need to find out how to do this. So we need to set the limits in which this movable jar has to move. For this purpose, I need to click on to the mate and go to the advanced mate. Now click on to the distance, and at this distance, before putting any distance, we need to assign the mate. Click on to this jar and this jar. Now as you can see here, with the by default value 1 mm, you can see there is a gap of 1 mm. If you set this gap to 0, it will automatically close to the point 0. Okay, but we need to specify the position by which amount it has to move until this point. So I have done some calculation how much amount we have to use or to enter at the maximum distance. Okay, as you can drag over maximum value or the distance it has to move. So while designing, I have figured out that the distance between this line and this line is 155, but 155 mm is the length of from this point to this point. But this is not just happening that, okay, because the length of this is also be considered, which is I guess 50. Yes, so the length of this is the 50 mm, so the 50 mm has to travel in 155. Okay, so this is the 0. If you entered value 0 from this point to this, it will, this point goes directly at this, and this surface just crosses at this point. So we need to minus 50 from 155, but we have these two plates attached together, or the jaws you can say, and the thickness of this jaw is 8 mm. 8 mm plus 8 mm, but it has some gap over here. So 155 minus 50 is 105, and upon some hit and trial method I find out that it has to travel 99, and click enter, click OK. Now as you move it, it just stop right there. So as you can see here, it is moving just in between these two points. It just ends at this 0 and stops at this point at 99. So all I find out by hit and trial. While I use it, the wireframe structure, you can see when I drag it, it just stops at this point. Okay, now converting it to click OK. Now it is time to place the screw mate between this shaft and this movable jaw, which means that when I rotate this handles, it rotates the screw rod, which in turn moves the movable jaw back and forth between the range. And how we're gonna do this? So for this purpose, first we need to find out where is the screw rod. There is it. I'm going to hide it for just temporarily. Go to mate, drag down, click on advanced mate, select screw. Now select distance per revolution, so it has to travel 2 mm per revolution. So that means one revolution of this in turns moves 2 mm of this movable jaw. Okay, but to make it even more faster, I'm going to increase the value of the movable distance to 4, just for the demonstration purpose, but it depends upon the pitch of the screw thread on the screw rod. So we have entered the distance. Now it is time to click on this and make visible show. Now select this one. Now as you can see, rotation is on visible. Click OK and hit enter. Now check if the screw mate is applied. Now screw mate is applied. Now if I rotate, the jaw has to move backward and forward. Dot and see what happens when I rotate the jar. So this is it. This is how you can now you can see the movement over here. So this is how you can place the screw mate and the limit mate in the machine wise assembly. So hope you find this information very useful. So if you I made this tutorial just to taking care of those person who already know that how to design all these parts. But if you don't know how to create those parts and wanted to know, then please write in the below comment section, so I will show you how to design all these parts very easily and conveniently by using SolidWorks. So guys, share it, like the video, and leave the comment whatever you think about this video. If you want more videos like these, so please let me know below in the comment section. Thank you.